Now we're going to look at transforming equations between polar and rectangular forms. So we saw transforming coordinates between polar and rectangular forms, and now it's going to be equations. So this first one, we're going to use the relationship that we just saw in the previous video, x squared plus y squared equals r squared, and replace this with r squared equals 9. So r equals 3. I guess we could say plus or minus 3, but plus or minus. Not sure that really matters, because if we were looking at our rectangular 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, it's going to be a circle, right? Not that this is a great circle. But when we look at the polar, 1, 2, 3, so if I did this circle with a radius 3, if I went negative 3, it's going to be the same thing. So there it is. So we just typically would call this r equals 3. Okay. Next one. X squared plus y squared equals 6y. So this one immediately, I probably want to jump to this again, being an r squared. And just recall what we had for y. It wasn't y equal to r sine theta. So we could change this into r squared equals 6 times r sine theta. And if we bring everything to one side, r squared minus 6r sine theta equals 0. And we could factor out an r, so it's r times r minus 6 sine theta is 0. So we have either r equals 0 or r minus 6 sine theta equals 0, meaning r equals 6 sine theta. Now, if we were to graph this original, and maybe Desmos is the way to do it. Maybe I should pull up Desmos and try that. Let me see if I can do that. So here is, let me drag it over here. There we go. Here is x squared plus y squared equals 6y. And here is r equals, there we go, r equals 6 sine theta. In fact, let me pull this out here and put it there. So I'm going to toggle between the two. This is r equals 6 sine theta. X squared plus y squared equals 6y. They look identical. So, okay, hopefully that helps. Let's go on to number 8. Rewrite the Cartesian Cartesian equation y equals 3x plus 2 as a polar equation. So we'll go back to, grab the wrong pen. X equals r cosine theta and y equals r sine theta. So r sine theta replaces the y, this y, equals 3 times r cosine theta replaces the x, and plus 2. So we have r sine theta equals 3r cosine theta plus 2. Now if I subtract 3r cosine theta, I can get the cosines on the one side. I would have r sine theta minus 3r cosine theta equals 2. The real goal is to get the r's on the same side, so I can factor the r out. R times sine theta minus 3 cosine theta equals 2. And solving for r, I'll divide both sides by sine theta minus 3 cosine theta. And r equals 2 divided by sine theta minus 3 cosine theta. That's how that would go. Wasn't that fun? Yes, it was.